Hello and God bless students. Welcome to our discussion on Module 1 in the course DS102 Discrete Structure 2. And for this lecture, we're going to discuss first on the introduction on discrete mathematics. We will describe here the definition or the meaning of the course, and also we are going to talk about mathematical statements such as atomic and molecular statements. We're going to describe and differentiate the two, and lastly we're going to discuss on 5 logical connectives. So firstly, what is discrete math? Alright, so it has an adjective of individually separate and distinct. So its synonyms are separate, detached, distinct, or abstract. So that is the basic of the meaning of discrete. So what is mathematics? So the study of numbers. It is a study of functions and lines and parallel parallelipeds and vectors, or perhaps it is a collection of tools that allow you to solve problems. And what sort of problems? So those that involve numbers, functions, lines, and triangles. So those are considered as problems. And whatever your conception of mathematics, we will just have to apply the concept of discrete to it. So it is defined as what I have mentioned, and some math fundamentally deals with stuff that is individually separate and distinct. So that is the basic definition of discrete mathematics. And in algebra or calculus, you might have found a particular set of numbers. Maybe the set of numbers are in the range of a function. So for example, we have uh, the interval of 0 to infinite. All right. So from there we can see that it has a range, or the function has range of 0 to infinite numbers, since the set of outputs of the functions are all real numbers 0 and greater. So the set of numbers is not discrete. So the numbers in the set are not separated by much, but in fact it takes any two numbers in the set and there are infinitely many more between them which are also in the set. So one way to get the feel, or to really practice on the subject, is to consider the type of problems we solve in discrete math. So on your module, you can view there simple examples. You can practice of some of the examples there are basic examples of discrete mathematics. All right. So here we're going to discuss about the atomic and molecular statements. But first, what is a statement? Okay, a statement is any declarative sentence which is either true or false. And a statement is either atomic if it cannot be divided into smaller statements. Otherwise, it is called molecular. So examples here, these are the statements that are called atomic statements. So first, we have telephone numbers in the USA have 10 digits. So statements, no, that are atomic are or statements that cannot be divided into smaller statements are atomic. So as what you can see in this example, no, dili siya pwede tungaon or i-separate. So another example here is the moon is made of cheese. 42 is a perfect square. Every even number greater than 2 can be expressed as the sum of two primes, and 3 plus 7 is equal to 12. So it can be either true or false. Those are called statements. And here, these examples are not considered statements. If you can see, for example, statement if uh, naa siya'y, or the statement that would ask, no, like interrogative questions or interrogative sentence are not considered as statements. And also this one, the sum of two squares, no, kay consider siya as fragment. Okay. And also this one in uh, numbers, no, mura siyang formulas are not considered as statements. And also uh, aside from interrogative, na ay mga na exclamation point na sentence, those are not considered a statement. And lastly, 3 plus x is equal to 12 are not considered a statement because it contains a variable. So the variable here is x, no? And depending on what x is, the sentence is either true or false. So we are not sure if the statement would give us uh, the result, or if it is true or false. So this is not considered a statement. So back to our others example. So makita nato nga some of these statements does not give us uh, exactly if it is true or false. So uh, those are not considered as statements. So one way to make the sentence into a statement is to specify the value of the variable. So mahimo lang ning siyang as a statement when we give a value, no, of this variable. For example, we write here x is equals 2, and then we include, no, this one in our statement. All right, so this will become a statement. Okay, so depending on the value, it will be either true or false. Okay, so you can actually build more complicated or molecular statements out of simpler atomic or molecular ones using logical connectives. Now, for example, this is a molecular statement. No, telephone numbers in the USA have 10 digits and 42 is a perfect square. Molecular siya in a way that we can divide or we can uh, break this down into smaller statements. No, the two shorter statements are connected by an and word kani siya. So mailhan nato og molecular siya if naa siya connectives, logical connectives such as and some other connectives, we will discuss also. That includes the this one, the or, the if and then, if and only if, and the not. So example of and connective, Sam is a man and Chris is a woman. So we can see here that we use the and, to connect two statement. We can also use or to connect two statement. Later we will discuss the we'll discuss more, on this connectives. And if and then, here is an example. If Sam is a man, then Chris is a woman. If and only if Sam is a man, if and only if Chris is a woman. And for not, Sam is not a man. So the first four are called binary connectives, si and, si or, if then, and if and only if, because they connect two statements, while si not is an example of unary connective. So since it applies only to a single statement. And these molecular statements are, of course, are still statements, so they must be either true or false. So the absolutely key observation here is that which truth value the molecular statement achieves is completely determined by the type of connectives and the truth values of the parts. And we do not need to know unsa tong mga parts, only whether those parts are true or false. So to analyze logical connectives, no, here we can consider this this called proportional variables, na sometimes called as sentential variables, usually on capital letters. No, these are just variables though, and we think of this as a uh, standing, in for standing in for our statements, and later we will use these variables. And also we have symbols for the logical connectives. This is the symbol for and, symbol for or, if and then, if and only if, and symbol for not. So you should memorize this one. I think naani siya sa inyong discrete structure 1 sa basic ninyo nga discussion uh, sa logical gihapon, no, and even other subjects of programming. So here is the logical connectives with the symbols and with the proportional variables being applied. Okay, so this is how we are going to read for the and symbol. P and Q is read as P and Q, also called as conjunction. P with a symbol of or, Q is read as P or Q and called disjunction. P with arrow pointing to right, P then Q, or if P then Q, is called an implication or conditional. With this symbol, na siya arrow that points back and forth with P and Q, is read as P if and only if Q and called biconditional. And not is placed before the variable is read as not P and called negation. So the truth value of a statement is determined by the truth value of its part depending on the connectives. So mag-usab-usab ang value ana depending on the connectives that is used in the statement. So here all right. So here are the uh, more of the discussion no sa ato ang connectives. So the first one we'll talk about either or. So sa ato ang language nga ginagamit no every day, either A or B means that one of the two options uh, holds no but not both. Since mupili man ta, that is why we use or. Okay, for example, when most people say something like you can have either a hot dog or a hamburger, so we use here or. It means that uh, we don't refer, or we don't, or based on option, based on the given option, we can only choose one, no? And they usually aren't offering both, no, based on our use of the connective. So the use of either or is usually divisive, no, and it means that uh, it means to imply that there are only two options, no, si A or si B ra gyud na, and not both A and B. So the use of or in this way is sometimes referred to as exclusive. So exclusive ang tawag. Okay? Since based on the statement, isa ra ato ang pilion. However, the use of either A or B in mathematics allows the options that both A and B hold. So the use of or in this way is sometimes referred to as inclusive. Okay? So inclusive siya in a way nga the two options that we have considered as marag boundary kung asa ra ang appeal. Okay? So for example, in mathematics, the statement if x is a real number, then either x is less than or equal to 0, or x is greater than or equal to 0. This allows the possibility that x satisfies both the given option kani siya. So x ko no satisfies both x is lesser or equal to 0. So makita na to nga kanida si x di ari, it's naa siya either x is a real number, no, makaingon ta nga x is real number if si x is less than or equal to 0. So unsa may pasabot ana? So kung kunin mo ning 0, this is the number line, no? Going here, going to the left is your negative, and going to the right is your positive. So since x is uh, lesser or equal to 0, subot pasabot, magsugod kang 0, 1, negative 1, negative 2, negative 3, and so on. Matawag na to na siya as real number. So based ani nga statement, or x is greater than equal to 0, kung magsugod na po 0, 1, 2, 3, and so on. So if inana ang value sa tong x, matawag yapon nato siya real number. So it means inclusive siya. Alright, so for this one, makita nato sa diagram nato, no, ang ang sitawan na ang ang visual sa visual sa kaning or nga connective. So makita na to si sa part ni A o sa part ni B, no, na siya color, and then sa tunga na siya a color pod, no. So either A, no, or si B. Actually other representation, no, actually wala ni dire, blanco ni dire sa tunga. So the opposite of this one is the and connective. Okay. So basically, in mathematics, the use of and also deserves a or the use of and uh, is a very same no sa ato ang ginagamit everyday. Wala siya same sa or no, and also wala siya murag different or special meaning sa mathematics. And just as we would expect, the phrase A and B no means that A and B must hold, or A and B is required maring ana. And for example here, consider the statement, if n is an integer that is divisible by 4, then n over 2 and n over 4 are integers. Okay, so although our example here, mura siya og if then no dili siya mura, but if then ang ihang form, but here we use and no sa ato ang then nga statements. All right, so if n is an integer that is divisible by 4, so kung mayong divisible by 4, that is kuan siya pwede siya pwede siya ma-multiply ani nga number, or pwede siya ma-divide ani nga number. Then n over 2 and n over 4 are integers. So for an integer to be divisible by 4, it must have, or it must be true no that n over 2 is an integer and n over 4 is integer. So we should satisfy this one kani. They should have a value so that it satisfies this statement here. Okay, but anyways, basic examples nga akong gihatag ganina, these are just, for example, this is a let me give you another example. So katong ganina akong gihatag no, asa naman to, let's go back. So this one as an example, okay kani siya. So basically given ani nga example sa and, so this is we can say if this is the P and this is the Q, kani siya. Okay, so A and B, kana siya. So we just have to to identify which variable no, or which propositional variables this statement will be kanang assigned to. So para mas madali ra nato siya ma-identify. So this is the Venn diagram of and connective no. So ang shade is nara sa tunga, so it means either of this one is required, and both of this one are required in the statement, so that it will be true. So based sa ato ang connectives ganina para ani, so P and Q is true when both of them are true. So it should be that both of the statement is true, so that mahimo po siyang ang value ani niya is true. So if we're going to create a truth table for and, so we can say that if both of them is true, we can say true man ni siya ang value ni A and B, right? Or ni P and Q. Okay, so na siya value nga, so mo ani ang value. All right, so if both of them are true, so the value is true. If one of them is false, of course, the value will automatically become false. And if si P pod is false and Q will become true, again, if one of the value is false, still false gihapon siya. So, if false ang duha, automatic, false gina siya diretso. So, this is called the truth table for the AND. Okay? Next is the if and then statement. So, if and then statement, basically if A, then B, if the statement is this one, if A then B, or A implies B, or this one, this symbol, we can either uh, use one of these three. So the conditions that make up A are the assumptions we make, no? And the conditions that we make up for B are the conclusion. So naatay assumption si A or the hypothesis, and our conclusion is B. So for example, in this example, we have N is even, or if N is even, then N2 is an integer. So kung ato ning i-convert into sentence, no, mahimo siyang if N is even, then N2 is an integer. Okay? So, if we want to apply a statement of the form if A then B, then we need to make sure that the conditions A, okay, so kung i-make sure nato kuno nga si conditions A are met before we jump to the conclusion of B. So kung natay na ning statement, we should always make sure kay si F, if A then B man, so we make sure nga ma-met ang condition ni A before ta moadto sa conclusion, which is si B. Okay, so in application, here we need to verify first that N is even, no, before we conclude that this is N over 2 actually. N over 2 is an integer. So N over 2 is an integer. Okay? So inana lang. So considering this example, we can say here that A is the statement, okay, this one, N is even, and this is the statement B, diba? So if we think about what it means to be even, no, namely that N is a multiple of 2, we see quite easily that these two statements are equivalent, no? So if we're going to give this one a value, for example, so for example, N, our N is, for example, N is 4. Okay, so since N is even, so makaingon jud ta nga kuan siya kanang nasa sa 2, 4, 6. So dili pwede 3 o 5 kay odd man si 5. So let's, for example, N is equal to 4. So we now have the value of N here. So mahimo na ni siyang 4. So 4 divided by 2 is 2. So makaingon ta nga true ni siya nga si B true. Before we can say, or we can say nga true siya given nga si N is also for example is 4. We assume that his value is 4, so maka-conclude na dayon ta nga na mao ni siya si B. Okay? So a statement of the form A then B sometimes means A if and only if B, no? For example, okay, let's go here. Kani siya nga statement. If aside from if and then, naapod tay ginatawag nga if and only if, no? So the statement A if and only if B is equivalent to the statement if A then B. Okay? So for example, n is even if n is even if and only if n over 2 is an integer. So, okay, considering this example, the statement A here is this one, same lagi hapon sa una na tong example, and this is the statement B. So again, makaingon ta nga si n is multiple siya og 2 kay even man siya. So we can say, for example, si n is equal to 2k. So given this assumption na 2k ang value ni n, then makaingon ta nga n over 2, kani siya n over 2 is equal to 2k over 2 equal to k. Okay, so kung si n kuno is equal to 2k, so atong i-derive n over 2 man ni siya. So n over 2, ilisan lang nato siya og 2k si n. So anong k man ang value? So makancel man ni siya kay naman siya 2 sa ubos. So 2 divided by 2 is cancel siya. That's why k na lang ang nabilid. So even this given this one kani siya nga assumption, so makaingon ta nga ang value niya is equal. So kani siya even lang ni siya if sa second statement n is even if and only if n over 2 is an integer. Okay? So naman na siya value dra nga 1. Yara. So okay, so I hope that is clear. For the negation, so to keep things to keep in mind is that if a statement is true, basically if ato siyang inegate, then the statement will become false. Okay? And if a statement is false, then its negation is true. So vice versa. So the most common negations are, first is the negation of A or B or the OR negation. So the negation of A or B is the statement not A and not B. So kung apply na to siya og negation, if we are given a statement and then ato siyang applyin og negation, the statement or kanang naa siya or the OR statement will become sorry. Okay, so the OR statement will become not A and not B. So for example, here, you are either rich or happy. Let A, rich, you are rich. Okay, mo na atong A na to, and then atong B is you are happy. So the negation of this statement, since not A and not B man, so very simple, no? Mahimo na siyang inani. You are not rich and not happy. For the AND negation, A and B, the statement will become not A or not B. So, mura ra siyang ibaylo. So, I am both rich and happy. For example, our statement A here is I am rich, and atong statement B is I am not happy. The statement or the statement applied negation will become I am not rich or I am not happy. Okay? And for the negation of if A then B, the statement, if the statement if this one, it should be replaced with the statement A and not B. So again, if I have an example like this, if I am rich, then I am happy. Atong A na to is I am rich, and then atong B na statement is I am happy. Kung applyan og negation, it will become atong A, I am rich and not happy. So si B mo na siya. For the negation of the this one, for every, for all, and there exist, no? O makita mo nga sa sentence. For example, if all rich people are happy, then all poor people are sad, no? Makita nato atong sentence diari nga naa siya'y ang form niya is in if and then, no? Where A is the statement all rich people are happy, no? And atong B, atong statement B is all poor people are sad. So since ang iyahang form is if and then man, based atong if and then nga rules, no? Ang manigate is si B lang, 'di ba? So atong inegate si B, it would be the sentence will become like this. So there exists a poor person who is not sad. So ingon na niyon siya, or you can actually uh, use a different term, there exists, or for all, or for every kanisyan there exists. Pwede ra na siya ilisan, no? So this one will become all rich people are happy, but there exists a poor person who is not sad. So mura siya ang mahitabo A, no? uh, Gamit matag ko diri all rich A, dayon ang B na to kani siya but dungagan lang na ni mag but dira, and then katong negated, no? Negated nga B sa original natong nga sentence. Okay? So next, so here is the summary, no, of the 5 connectives, no, for the statement A or B. If negation will be applied, so the statement will become not A and not B. And for the AND, the negation will be not A or not B. Kung if and then, the negation is A and not B. And if the statement na siya for all x, and then A, function of x, it will become there exists x such that not A of x. And there exists x such that A of x for every x, not A of x. So, ina na ang iyahang negation. So, note that for us, or is the inclusive or inclusive or, and not the sometimes used exclusive or. Meaning that P or Q is in fact true when both P and Q are true. Okay? So, mo na result niya. So, as for the other connectives, and it behaves as you would expect, no? As does negation. The biconditional if and only if might seem a little strange, but you should think of this as saying the two parts of the statements are equivalent in that they have the same truth value. So kung unsay value ni A, kung true siya, dapat mapod ang value ni B. So true pud dapat siya. So this leaves only the conditional uh, if P then Q, which has a slightly different meaning in mathematics than it does in ordinary usage. Okay? So that's all for the discussion of Module 1. I hope you guys uh, uh, understand the topic well. And if you have any questions, you can uh, ask me, or you can post in the G Classroom, or you can ask me on the using Messenger.